Imagine having the power to delete sound, not just turning it down or muffling it with thick padding, but actively erasing it from the air before it reaches your ears. This concept, which sounds like science fiction, is the fundamental principle behind active noise-canceling headphones. They don't simply create a physical barrier, they engage in an elegant and sophisticated act of sonic warfare. They create a new, carefully crafted sound designed to fight unwanted noise, annihilating it in the tiny space around your eardrum. This process is a remarkable feat of engineering, turning sound itself into the ultimate tool for creating silence. The idea can feel counterintuitive. How can adding more sound result in less sound? Yet this is precisely the magic that noise-canceling technology performs. To comprehend how sound can be cancelled, we must first understand what sound truly is. At its core, sound is a form of energy that travels as a wave. Imagine dropping a pebble into a still pond. Ripples spread outward from the point of impact. In a similar fashion, a sound source like a vibrating guitar string or our own vocal cords creates vibrations that travel through a medium, most commonly the air around us. These vibrations are not a flow of air itself, but rather a chain reaction of pressure changes. Air molecules are pushed together, creating zones of high pressure, and then pulled apart, creating zones of low pressure in a repeating pattern. This invisible dance of molecules is the sound wave. Our ears are incredibly sensitive instruments. When a sound wave reaches the ear, it causes the eardrum to vibrate with the incoming pressure changes. The brain then interprets these vibrations as sound. The characteristics of the wave determine the nature of the sound we perceive. The rate of arrivals, the frequency, determines pitch. Slow waves sound like bass, rapid waves sound like treble. The height, the amplitude, determines loudness, from a whisper to a jet. The secret to making sound disappear by adding more sound lies in interference. When waves meet, they combine. Crest meets crest, the effects add up. Constructive interference makes sound louder. Invert one wave. Crest meets trough. Equal and opposite pushes work against each other, and cancel out completely. The surface looks flat. Silence. This is destructive interference, the core of noise cancelling. ANC identifies the shape of the unwanted wave, then generates a mirror image, same amplitude, but inverted phase. Peak meets trough, and when both arrive together at the eardrum, they negate each other. The result? Dramatic reduction in perceived sound. +5, -5, equals 0. Headphones repeat this equation in real time, millions of times per second, creating a zone of relative quiet. To execute destructive interference, active noise-canceling headphones rely on a trio of components working in harmony: microphones, a processor, and a speaker, a miniature ecosystem of listening, processing, and broadcasting inside the ear cup. First, microphones, tiny ears that capture the ambient noise from the outside world. They convert physical sound waves into an electrical signal the system can analyze. Next, the noise-canceling processor, the brain of the operation. It analyzes the incoming signal in real time, determining frequency and amplitude, then generates a new signal. The exact inverse, the anti-noise. Finally, the speaker, the driver, converts that electrical anti-noise into a physical sound wave. It projects the anti-noise into the small space between the driver and your eardrum, where the magic happens. There, the manufactured wave meets the original noise that leaked through the padding, and they cancel. All while your music, a podcast, or a call plays, the system distinguishes what to cancel from what you want. The speed and accuracy of mic, processor, and speaker determine ANC quality. The three methods of cancellation: feed-forward, feedback, and hybrid. Feed-forward, a microphone on the outside hears the ambient noise a split second early, sends it to the processor, which generates anti-noise in anticipation. Very effective on constant, predictable sounds, with wide frequency response and no internal feedback loops. But it can't hear what you actually hear inside the ear cup. It operates on prediction. If fit shifts or wind hits the mic, it can't autocorrect and may be disrupted. Feedback. A microphone inside the ear cup monitors the result. It hears the original noise, the anti-noise, and your music, and sends feedback to correct inaccuracies in real time, adapting to fit. Hybrid combines both. One mic outside for proactive capture, one inside for corrective feedback. With a more complete picture, it generates more precise anti-noise across a broader range. Hybrid typically cancels best, but is more complex, more expensive, and consumes more battery. Different designs, same physics, cancellation via carefully timed, inverted sound. The bass clef of cancellation. Why low frequencies are easier. Think airplane rumbles or train drones. Low frequencies are long, slow, and repetitive. Predictable patterns the processor can measure, compute, and invert in time. Cycle-to-cycle shapes stay consistent, letting it predict the next millisecond for precise anti-noise and near-perfect cancellation. The result, profound, quiet. Low frequencies are hard to block physically, so active cancellation wins. High frequencies like speech are short, fast, and complex. A jumble of changing frequencies and amplitudes with no stable pattern. By the time the mic captures and the processor computes, the wave has changed. Latency makes anti-noise arrive late or mismatched. You hear residual muffled remnants and our brains notice speech leftovers more. Padding blocks some treble. ANC excels at slow bass. Passive isolation handles many highs. Active cancellation tames the slow, steady giants. While powerful, ANC is not a universal delete button. It operates within physical and technological constraints. Fit and seal are critical. Gaps from glasses, hair, or poor fit let noise bypass the system entirely. Over-ear designs with plush pads generally cancel better than on-ear or loose models. Wind is a major challenge. External and hybrid mics are very sensitive to turbulent pressure. The processor may treat wind like loud low-frequency noise and play aggressive anti-noise, creating a whoosh. Many headphones now include wind reduction algorithms, but it remains tricky. Sudden, sharp sounds, transients, are also hard. The event can end before detect compute playback completes. Some reduction happens, but cancellation is incomplete. High pitches remain challenging. Passive padding does much of the treble blocking. Understand the limits, fit, wind, transients, and highs to set realistic expectations and get the most from ANC. With the right setup, ANC shines. Practical tips for better noise canceling. The single most important factor, a proper fit and tight seal. Adjust the headband so ear cups sit around your ears. Try different pads and materials. A good seal prevents leaks. Foundation of passive and active cancellation. Check pad condition. Compressed or cracked pads ruin the seal and reduce performance. Replace worn pads. Like tires, they wear and need maintenance. Keep firmware up to date. Algorithm updates can improve cancellation and fix wind issues, or add new features. Use ANC where it helps most. Travel, noisy cafes, open offices. In very quiet rooms it may add a faint hiss and uses more battery. If wind is a problem, some apps let you switch from hybrid to feedback only, disabling the external mic to reduce whoosh. Manage fit, maintain pads, update software, and be smart about usage to maximize your quiet focus. Quick recap. Sound is a pressure wave. ANC listens, analyzes, and plays an inverted wave, destructive interference, to reduce noise. Microphones capture, a processor computes anti-noise, and the speaker projects it near your eardrum. 3 designs: feed-forward, feedback hybrid, trade simplicity, correction, and performance. Low frequencies are easiest highs and transients are harder. Fit and wind matter. Maintenance and updates help. Where do you use noise canceling the most? Plane, office, or gym?